is the design director. Is the design director of Lake Flato Architects, and I've had him in my lighting class since, I don't know, like a decade now, right?
Been a
So it's
long
contributed so much to lighting education in Minnesota, in North Dakota, and I'm sure in Texas and globally as well. He's also the chair of the IES Building Information Modeling um,
standards.
standards.
Yep.
And it just collaborated and developed like a technical manual for the BIM standards for IAS. So just to show you how versatile he is, and it's written like over 2 dozen BIM books, right? Building information modeling books. So I just want you to welcome Dan, and I'm just going to defer to him and let him present. Thank you, Dan.
Yeah. Thanks so much, Abby. It's super appreciative of you trusting me to talk to your students, and of course you're on the BIM standards committee with me, so it's been really great. And she actually wrote the foreword to my interior design using Autodesk Revit textbook. So we have lots of intersections, which is really fun. All right, I'm going to share my screen and just jump right into the material. Some of the slides allow me to introduce myself a little bit more, and then also the company I work for. So, can you see my screen okay?
Yes, we can. And it's okay to record this, right? Yeah, thank you.
Yes, for sure. No problem. Okay, so I always like to start presentations with this fun slide. It kind of gets to the culture of our firm. It's actually has a really well-known and sort of admired culture throughout the architecture community. And one of the things that's really fun is going to Ted Flato's ranch in West Texas. So Lake Flato is two people, David Lake and Ted Flato. And once a year, we spend a long weekend, so 3 days at Ted Flato's ranch in West Texas. And people bring, you can see there's kids, family, and significant others. And it's just a fun weekend of eating, drinking, dancing, swimming, and repeating all that stuff. There's a couple of Jeeps where we go driving into the countryside, and people go to these like remote swimming holes, and like just really fun. No talking about work, no team building exercises. All that stuff's for some other time. This is just a fun time out. And so about me, as Abby mentioned, I'm actually we both previously were in Minnesota. I'm a registered architect. You can see by the picture on the right that I literally used to live in Minnesota, and used to bike to work and down to minus 20 degrees. And in Duluth, Minnesota, where I lived, it was climate zone 7, which is the coldest climate zone in the United States. And it would actually get minus 40 sometimes, which interestingly enough is the same. Minus 40 Fahrenheit and minus 40 Celsius is the same thing. It's one only place that the two systems overlap each other is at minus 40. So yeah, I've written a bunch of textbooks. I have a blog that you might be interested in called BIM Chapters. It gets like 20 to 40,000 views a month, depending on if I'm writing anything interesting. And then I also am paid occasionally, so I'm commissioned by Enscape to write blog posts for them. So if you're familiar with the real-time rendering software Enscape, and you go to their blog, you'll see that I've written a number of the articles. One of them is on electric lighting design and how Enscape isn't really designed for that, but paired with this other software I'm going to show today, you can really do some great design, like directional analysis. And in addition to being on the IES committee, there's an AIA committee called the American Institute of Architects, and they have a committee called Committee on the Environment. And I'm on that national committee on the environment leadership group. There's 12 of us that oversee all things that relate to COAT. And then I, as I'm doing right now, well, actually first, I am an adjunct instructor So I teach graduate architecture students at North Dakota State University. I actually have a class right after this one. So the students are in Fargo, and I'm the only one who's really not in town. Most of them are going to regular day classes, and in fact, one in the past before COVID, all the students had to be in the classroom like they are in this picture on the left, and I was the only one remote. In this particular picture, I was actually in the room. Um, and then I present for other universities like yours, and you can see Abby in the lower left when she was back in Minnesota. Selfie with us. Here's the covers of a bunch of my textbooks that I've written. Shameless plug. Here's a plug for the IES, and this, mentioning this is obviously relative to the topic of talking about lighting design. So today I'll be talking about daylight and electric light design. And so IES kind of covers the whole gamut of the Illuminating Engineering Society. And this is the committee. So there's my name and Abby's name, and then all the other great people that we had on the committee. And in fact, from around the world, even we have, even though it's an American, IES is a ANSI committee, so the American National Standard. We still have somebody from Mexico and somebody from, I forget what country in Europe, and then Brazil. And then another interesting thing, when I used to work at a firm in Minnesota called LHB, it was a multidiscipline firm. We created this thing called the MEP Productivity Pack, which had some lighting functionality in it in terms of Revit light fixture content and being able to create light fixture schedules for construction documents. We actually started selling this thing, and it's still being sold. I'm not involved in it anymore since I left that company. But before I left that firm, it had grossed over $1 million in sales and probably doubled that by now, I'm sure. But we won an ACEC award. So ACEC is sort of like AIA, but for engineers. And then another interesting thing related to lighting design is I have a side gig, as if I didn't have enough already to do with working full time, and then also having this adjunct professor job. Once a quarter, I do training for lighting design professionals on how to use this add-in for Revit called ElumTools that we're going to talk about today to do lighting calculations. And then Lake Flato, have any of you heard of the firm before? I'm just curious. Actually, I need to turn on chat so I can see that. Maybe you can give me a thumbs up if you've heard of it. If not, no problem. A lot of people haven't heard of it because it's actually a fairly small firm that's mainly based in Texas, but they've done lots of really cool things. So I'm going to tell you about that right now. We have 2 offices, San Antonio, and then a smaller one that started just a few years ago in Austin. But actually, just 2 months ago, we announced a new office in Portland, Oregon. They've actually been working 6 people together in a WeWork for the last 2 years, but recently became officially an office. Last year, our 2 founding partners, David Lake and Ted Flato, won the AIA Gold Medal Award, which is the highest award any individual architect can win in the United States. And then in 2019, Architect Magazine ranked us the #1 architecture firm in America, which is pretty cool. And then I mentioned COAT being a committee, but there's also this award, the COAT Top 10 Award, and maybe you've heard of the COAT Top 10 for Students Award. So there's a professional version and then a student version. So if you haven't heard of it, you should definitely look into this and apply, like submit a design. The process of doing, working through a project in a studio and then submitting it is super valuable because you learn a lot about the framework for design excellence, the AIA's like strategy for designing high quality, equitable, environmentally sensitive projects. And anyways, Lake Flato's won more of the Coat Top 10 awards than any other architecture firm in America as well. And that's 16 total. Doesn't sound like a lot, but that's been over like 10 years, and that's more than any other firm. The picture on the right is the Austin Central Library in downtown Austin. And in 2022, we won a Time Magazine award for a 3D printed house we designed in Austin. We have 5 studios, a single family residential studio. So there's an example of one of those projects on the left. And then we have learning, which is K through 12, higher education. We have projects, we've had projects all over the country, and right now there's 2 projects at Cornell and 1 just finished at UPenn. And in the lower right, we have a urban development studio, and I was actually just at this project that's shown here for lunch today. It's called the Pearl, and it's a large urban renewal project. It used to be a really large brewery, and it went out of business, and then it was an empty sort of you know just empty buildings for many years, and the developer turned it into this really amazing space. And then in the middle bottom is the Eco Conservation Studio, which has the coolest name, right? They work on projects like we have projects right now at the Houston Zoo. They do botanical gardens. They also do hospitality projects, and all of their projects are projects that are like sustainable and connect with nature. And then here's just a little snapshot of projects that we're working on. We actually have some projects, and you see one on the left there is in Hawaii. We have another one in the right in the sort of the Caribbean, the Cayman Islands, and there's one in Fiji that doesn't show up on this map, and one currently in Mexico. I guess it is showing up here in down there, Baja in the lower left. So here's a couple of samplings of the Code Top 10 projects, and just a little bit more rambling on the firm, and then I'll start on the topic at hand. But these are just a few of the projects that have won that Coat Top 10 award. In the upper left is a project that was also the first Living Building Challenge in Texas. And at the time, it was like the 7th or 8th in the world. The lower right, this World Birding Center, it won this award in like 2006. And it talked in the description about low embodied energy. And now we typically say low embodied carbon, which is synonymous. It was also designed for deconstruction, which is really cool, supporting that idea of a circular economy and material reuse. And then another fun one in the lower left, we actually won a Coat Top 10 award for a grocery store, which is highly unusual. And interestingly enough, HEB is sort of not just any grocery store. It's on the Forbes top 10 privately owned companies, and they have 100,000 employees. My daughter worked there for like a year, and every single employee gets a full turkey at Thanksgiving. There's one grocery store on the list that's on that top 10 list that's bigger, and it's called Publix. Right? Some of you have heard of that as well. It's in Florida and states around there. Anyways, fun fact. And then when it comes to like design performance in general at our company, daylighting and electric light analysis is definitely in that lane. But just real quick, more holistically, we have a 5-person dedicated design performance team. I'm one of those 5 people, even though I wear several hats. I also lead our internal research program, so I do lots of things. But the other 4 people are like 100% dedicated. They might build time to a project that they're working on to do design performance, like energy modeling or embodied carbon or daylight analysis. But generally speaking, they're not doing production work on a project. They're all focused on design performance. So 5 people in a 160-person firm is actually a really good, like high ratio for that kind of dedicated role. And so in this graphic, the top half, the green stuff is like internal things that we do. And on the left is like the beginning of the project, and to the right is the end of the project. So we're always starting out doing this design performance analysis. like a microclimate study before even designing anything. We will do that to understand the project location. And then the bottom half of this line is like client or public facing stuff. So another thing we do before we start drawing anything usually is this integrated design workshop. So this picture on the right happens to be one that was held outside. Um, and I don't know what your weather's like there. I love rubbing this in a little bit since I used to live in Minnesota, and I'm sure in the Northeast it's a little chillier out than normal. But right now we have uh, it's 84 degrees out and it's quite comfortable. 47. Oh my gosh. Yeah. So our low today is 69. So anyways, we can have meetings like that outside. Yeah, 84 degrees. I literally had lunch at that place I told you outside in this short sleeve shirt. Like I said, sorry, I had to rub it in a little bit because I used to live in the north. Um, but we do this thing, the integrated design workshop is getting everybody together, like the mechanical engineer and the electrical engineer and the structural. A lot of times they don't really start in earnest on a project until like mid DDs because they want to wait until things stop moving around before they start doing stuff, calculations that they would have to redo. But if we get all of them together, and then on the owner side, trying to get them to get the and trying to, we can't obviously force our client to do anything, but we try and get them to get the building occupants, the maintenance people, and the people who are the decision makers together early on. And this bottom part here, the integrated design workshop plus goal setting, so we want to work with them to set the goals. We don't dictate whether they're going to do a lead project or some green building certification. They need to tell us that because they also then need to support it when, decisions come up, and if there are more costs or time involved, it doesn't have to always cost more or take longer. But if we all decide early on what the goals are, and then we create a report and like a spreadsheet to track those goals through the project for some accountability, and then if along the way anybody starts to deviate, we can go back to this record and say, hey, look, this is what we decided to do. This is gonna like deviate from the goal. So this is part of what we call our secret sauce and how we've won so many awards, so that sort of the proof is in the pudding. We got all these great projects, great awards, really happy clients. And so we call it our secret sauce, but we tell everybody at conferences all the time, we'd love for everybody to have amazing, high performing buildings. Um, and then also the really great people at other firms, we want them to come work with us. There's all kinds of win-wins. And so then as we go on, we're doing performance analysis all along, like energy modeling and daylight analysis. Actually, there's a software I'm going to talk about today called Climate Studio, and they have a blog, Climate Studio Lake Flato blog. So they wrote a blog post about a project that we did using their software. I'll put this in the chat. And the most significant thing to take away right now for you to just think about and read it later is they are highlighting the fact that early on in the design, before things got too locked in and we've shown it to the client too much, we did a bunch of daylight studies to make sure that the daylight was performing optimally. And in that blog post, you can see the very initial study had some really poor performing spaces like a gymnasium and a classroom like on a corner. And you can literally see the design change and the performance improve. And so the main point is that if you wait too long to do energy modeling, to study passive strategies like window to wall ratio and roof and shading and orientation, or daylight analysis, and you can't change stuff, like the client's already seen it, they've signed off on it, um, then you're really just doing it to check a box and it's not as beneficial. So that's why we have this design performance thing multiple times. And then we also will support doing research, and we'll even train the designers on the teams if they want to do some of this stuff themselves. That's even better, because for some reason when they're working on a deadline and it's 2 a.m. and they email us and we don't respond right away. I'm just kidding. Obviously, they do work late sometimes like that, and we're clearly not responding to an email at 2 a.m. So they can do it themselves. They can do an analysis and see, oh, that's not great, and make a little change and do it again. And then the very last thing that we really like to do, but we can't always do it because the client has to approve it. And sometimes we'll do it for free, but the client still doesn't necessarily want to spend any of their time doing it. Post-occupancy evaluation, where we're actually going to the project after it's done and taking readings, or they're sending us their energy bills, or we've installed a monitoring system that we can access remotely, just to see if it's really performing the way we wanted it to. A school we designed in Houston, one of our design performance interns and one of our design performance team members went to Houston for 2 days, and they walked around with a light meter in the spaces where we did lighting calculations, right? Virtual lighting calculations before the building even existed. And then comparing that to real world numbers to see if they matched, which is really cool, especially when they do match. And I have an example of that later. And then this is just a quick example of a microclimate analysis. So this is a lot of data that's been extracted out of a historical weather file for a specific site. And this graph just shows the idea of what I mentioned. Like if you do analysis early, there's a lot of ability to control the design. And then if you wait and do it later, there's less ability to control design, is basically what this is saying. And we use lots of tools. Today we're going to talk about a few, like Climate Studio, and then ElumTools is an add-in to Revit, and then a quick touch on Forma. Probably won't have time to get to Fenestor Pro. And actually, let me see. So we have 1 hour, right, for this?
Yes, we go till 5:30. So yeah, technically you have 1 hour now because it's 4:25.
Yeah, okay.
So 1 hour.
I rushed in late. I couldn't remember for sure what time we were done it. So yeah, so I'm gonna just jump in. We have resources, like I mentioned, we'll teach our designers how to do this lighting design if they want to do it themselves. And then if they want to look up information, we have information on our intranet about glass types and things you want to keep in mind when you're doing daylighting calculations. All this is custom created for our office. And there's a little user guide on how to use the software if they need a refresher. We have templates in InDesign to be able to drop the results in and make the final presentation look the same, and saves them time. They're all really creative, and they all really want to create their own title blocks and stuff, but that's not really the best use of their time. So we make these templates available. And then the templates have like these these legends and little blurbs for both us and the client to understand what is annual solar exposure or useful daylight illuminance, and what's a typical good range. So all that's on there ready to go. And then this is actually that same blog post that I just shared with you. There's a gymnasium that went from 65% spatial daylight autonomy in the left to 100% spatial daylight autonomy. That means theoretically 100% of the time during the day, you wouldn't need artificial lights in the gym. And so for our office in San Antonio, we actually achieved WELL Building Platinum, which is a green building certification, similar to LEED or zero carbon. But WELL Building is it's about the building and the health and wellness of the people in the building. So that's why for our office, we decided to go this route. And one of the measures that you have to do is calculate for light. And, well, there's a bunch of things you can do to get credits, and then the more credits you get, gold or platinum or different levels. So we got lots of credits and got platinum, and part of that was doing daylight calculations and electric light calculations. The electric light calculations are actually what's called a prerequisite. You have to have good quality lighting in the building so people don't get like stressed when they're doing a task. They can't see well, or it's too bright and it's giving people headaches and there's glare. So you have to do these calculations to show what the quality is. And so of these 10 measures in the light area, there's 2 preconditions and then 6 things you can do. So for all 10 measures, you have to do all the preconditions for every single one of them, or you can't even get certified at all. And so within light, there's the 2 prerequisites and then the other things that you can do. So calculate light and daylight. So for daylight, these are the 2 ways in which you can do the calculations. And we chose to do the calculation where we're doing a simulation. And this is a video. So in the past, I've done this live, but it's easier to do a video. So I don't go over and you get all the content. So I'm going to hit go here, and this is going to go, this is a, I think, yeah, an 8-minute video. So I'm going to talk over it. And I like showing this just to impress upon you how generally straightforward the process is. Like in 8 minutes, I'm going to take a Revit model into Rhino, and Climate Studio is an add-in to Rhino, and do a full daylight calculation. So in Revit, this is just showing that it's a kind of a messy model. This view is set up to export to Climate Studio, so a bunch of stuff is turned off, just the essentials. This is showing that the true north is set, and then also all of the sort of purple colored glass. Notice how it has a special glass category called glass in Revit for the material. And then there's another type of glass for skylights. And I just made them different colors so that they were obvious in this video. They don't really need to be the different colors. But now if we go to this glass type and look at the Revit material, notice it's orange. And then on the identity tab, the glass it's also set to category glass. And then this also happens to have a design option. Again, it's a messy normal model. Now, Climate Studio has an add-in for Revit, and its sole purpose is just to get the Revit model into Rhino in a way that's optimized for, notice how it's looking for the material class is glass. That's how it knows that those 2 glass types are something it should consider for daylight. And then these are the categories. You only want to bring in the walls, the floors, the ceilings, the roof, the windows, and the curtain wall. And then the lower left, there's an important checkbox there for export rooms. That'll put a polyline around every room, because when you're doing daylight calculations, you need to specify which rooms are occupied. It doesn't matter what the daylight levels are for a storage room that nobody sits in. Now, if there was a desk in there for a storage room manager, then it would be occupied. But here I'm importing that exported Revit model using that special file. And notice how, if you're familiar with Rhino, it created all these layers in Rhino that actually match the Revit categories. And not only that, it also applied a special surface property to each one of those layers that we'll look at in just a minute. Because when you do lighting calculations, the surface reflectance is really important. But notice there's 2 glass types based on the material and the option. And I can specify all of these real world glass types. So the visual light transmittance is an important value, like how much light comes through that glass. Some glasses are really dark and don't let much light through. And so here's the skylights. So the regular glass and the skylights came in as two separate layers in Rhino, which makes it really easy then for us to specify the visual light transmittance value for those two different glass types. And here I was just showing that you have to pick the weather file. That's really important. So it knows where you are on the Earth. Are you close to the equator? Are you close to the North Pole? And then when I told it to export rooms and it put a polyline around each room, that polyline even had the room name and number in it. So now this list of the rooms in the project make it really easy for me to uncheck the ones that aren't occupied, the toilet rooms and the janitor's closets. None of those are occupied. So when you do a lead daylight analysis, you have to have a certain percentage of spatial daylight autonomy to pass, or well building as well. But if you were to include the unoccupied rooms, you'd always fail. So now that we've imported the Revit model, we've looked at the surface properties of the walls and the glass, and we've unchecked the unoccupied spaces. I click the play button, which runs a simulation and will tell you the quality of daylight in every single room. And also at 30 inches off the floor. That's the typical surface that you're calculating light, which is the height of a conference room table or a desk in an office. And I know I'm talking fast and there's a lot to cover, but it is being recorded. So someday when you're having trouble falling asleep, you can play my video and listen to my annoying voice. I say annoying because I don't know about you, but I feel like most people don't like the sound of their own voice. So here are the results on the right. And then you can export probably one of the super most helpful things is this lead report. It's going to make a PDF, and it's going to, even though we're talking about well building, the lead metrics are still very similar. They're doing that same LM83 analysis that was required earlier. So here's the final result. It shows you the spatial daylight autonomy and the annual sunlight exposure. And then it breaks it down by room. And so now I'm going to move on just to keep going here. There's, yeah, I think we have time for this. The ElumTools software that I'm going to show you for the electric lighting, it also has the ability to do daylight calculations, but only for a specific point in time. So it runs fully in Revit, which is nice. Let me back up and just show that one more time, what's happening there. So for the Revit model, when I click on the material mapping, all the Revit categories, there's one in particular for exterior light, and you can set the visual light transmittance value. And then for the other categories, for the walls, the floors, the ceilings, it has a default reflectance value that's just applied to every Revit wall and every ceiling. And then you go into this daylight dialog box just to make sure that, because I said it's a point in time, so here you're picking September 21st at 9 a.m. And then once you've specified the surface properties, you've specified the glass properties and verified the true north, then you can run a calculation. When you select a curtain wall in Revit, it has a built-in parameter where you can tell it whether it's an exterior or interior curtain wall. And that I was just showing there a minute ago that that's also important for ElumTools to know what's an exterior window and where daylight's coming in versus an interior window that's daylight's not coming through. you have to specify that using normal Revit best practice workflows. Just showing here that this is actually using quite a bit of your CPU and your GPU when you're running the calculation. And then once it's done, this is pretty nice because here you can actually have more detail, like some of the furniture, and see the point by point illuminance calculations. So these are numbers in foot candles of how much daylight is coming in. And of course, the desk closer to the window is going to have a higher number. Once you've done the calculation in Revit, again, like completely in Revit, you can see the points or this spatial map to see where the hotspots are. This software has the ability to make a Revit schedule. So once you've created this Revit schedule, then once you start doing the next rooms, more rows will show up. You don't have to make the schedule again. Also, I see a comment from Elizabeth mentioning that it's cool that they have an add-in to easily transfer from Revit to Rhino. A super cool thing that isn't public yet, but they told me I can talk about it, is Climate Studio is making an add-in that's 100% going to be in Revit, similar to what ElumTools is doing here. And that'll make it even easier. All right, so electric light. Any questions on daylight before I move on? Glad to see comments coming in the chat. That's awesome.
Hello, I have some questions.
Let's hear
I also use Climate Studio. My question is that how do you decide which tool is better? Because sometimes I hear Climate Studio is not the best. And also my other question is, people who run this simulation in your firm, are they in architecture? Because this is another thing that I usually hear, that they say that even if you learn this as an architect, they usually hire engineers to do the simulation and work on energy building performance tasks.
Yeah, those are really good questions. So the first thing about Climate Studio, it is really a sophisticated tool. It's the only daylighting tool we use in our office, and the people who make it are like really amazing academics. They actually teach
Solema.
or have taught at MIT and Cornell, and
Yeah, Solema. They are called Solema.
can you hear me okay?
Yes, yes, yes.
Okay. What did you say? I didn't quite
I'm
catch that.
saying that the team is called Solema.
Yeah, the company's called Saloma. Yep. And they have some really great books. It's funny, I didn't have these here as a plant. I actually had them within arm's reach. So the
Mhm.
author, the person who made the software, Christoph Reinhardt, he has some books here on how to use how to do daylight design. I don't, these don't even necessarily talk about the software. They're just academic books on doing high performance design. But we find that Climate Studio can do pretty much everything we need. We're using it right now on a large $1.6 billion airport project, and we've studied multiple things like shading, frit, electrochromic glass. They have the ability to create surface or material definitions that are based on real world inputs, so that reflectances and things like that are really accurate. I'm sure there's some things it can't do, but it's one of the best ones, I think. Autodesk has something that actually does work, but it costs cloud credits, and it's a little bit complicated to set up. And then there's a Light Stanza, which is also pretty tied to Revit, and is a good one. But Climate Studio, I think, is overall the most sort of sophisticated. And if you know Grasshopper, you can actually connect it to Climate Studio and do even more things, which is cool. And then the question about who does it, it depends on the firm. There are some firms that like to outsource their sustainability work. Some firms don't do any sustainability stuff. They're just doing kind of best practices, which isn't really sustainability. It's not, bad, but it's not the best workflow. And some of those have it in-house, some of it outsource it. Some architects do it themselves on a project team. There's a lot of variations. There are professional lighting designers that most of them are doing electric light design, not necessarily daylight design. Some of them can do it. So it varies quite a bit. There's so our company does it, as I'm obviously telling you, but then there's consultants like a company called Italia 10 that has offices all over the US and based out of London that can do electric and daylight calculations. What type of software program are you using for the Revit model to create the light calculations? Yeah, so that was ElumTools. That is an add-in for Revit that I just showed that does the daylight calc. And then now in the electric light, we only use ElumTools for that instead of Climate Studio, because that's all in Revit, single source of truth. So ElumTools. And then Professor Shanklin, you have a question?
The same question. Actually, what type of software? You just answered it. ElumTools. So that's something that's integrated with the Revit software.
Yeah, it's not made by Autodesk, but it is free for students, but only if the professor requests it. Students can't get it themselves like they can Autodesk software.
Okay, I have one other question.
Yeah.
Are you able to utilize like a 3D Max model to do the same type of lighting calculations if you had to bring that in, or is that something separate? Because I know that's under an Autodesk.
Yeah, that geometry doesn't work. Well, it might work if you brought it into Rhino to do Climate Studio Daylight. If you would have to make sure everything was on separate layers so that you could apply the surface properties. And the thing before the Revit add-in, like Climate Studio didn't used to have the Revit add-in that would export to Rhino. And we had to run a Grasshopper script to flatten the glass. So all the glass had to be a single plane surface. And so you'd have to do that probably if you were bringing in a 3ds Max model. So I think that would work in Rhino. I know 3ds Max does have some sort of lighting calculation capability in it, but I don't know how accurate it is. I've never used 3ds Max at all myself, so I just don't know.
Okay, I just thought I would ask, but thank you for answering my question. I appreciate it.
No problem. Let's see. Any other questions before I move on? I love this. You're all asking already twice as many questions as most lectures I get, which is amazing. It's good to keep it interactive. I mean, because you have a question, I bet you your classmates maybe have the same question and are happy you asked. Okay, so this is similar for daylighting, but this particular slide I like to share when I'm doing training on lighting design. So in my class at NDSU, we have a module on ElumTools, and I go through the steps of getting the software for free for the semester for the students. I also tell them while they have it, they should start working on using this in their other studio classes and incorporating it in their portfolio. Having something like this 3D view with the calculation points floating in space tells the story itself that you have done some design performance stuff when you're trying to get a job versus a bullet point on your portfolio or in your CV or your resume. So in your portfolio, having this kind of stuff, it's going to set you way ahead of other people you're competing with, in my opinion. But to do lighting calcs, you need the spatial geometry, right? The room needs to be modeled. the surface properties then need to be defined. They have a reflectance value. So lighter colors are higher reflectance, darker colors are lower reflectance. So when the light's leaving the photometry, which is the next thing, the photometry has to exist and has to be positioned. When the light leaves this thing, it's going to hit the surface and and reflect. And so by the time the light hits the point that you want a reading from, some of it's direct light and some of it's light that's bounced off of adjacent surfaces to give you the cumulative foot candle number. And then if you don't know what the materials are, which 90% of the time we're using the IES rule of thumb method, 20, 50, 80. So the floors are 20%, the walls are 50%, and the ceilings are 80%. If it's a special space and we know the materials, we'll plug in the actual number. But then Revit families also support IES files. So you can create a Revit family with the proper IES file from the manufacturer. So most legit, architectural light fixture or architectural lighting fixtures, which essentially means a professional grade light fixture, they're going to have had a third party define mathematically how the light leaves the fixture. And this shape that you see here sort of defines that. This is a direct indirect pendant. So light's going down and light's coming up. Interestingly enough, separate from any extra software, Revit all by itself can calculate the average estimated illumination, but it's a little tricky because it uses some stuff that architects and interior designers don't normally use or even know about. Notice up here in the properties, it says I have a space selected. Architects and interior designers are usually placing a room object, which is the right thing to do. But if you place a space object, which is the exact same thing as a room, except it holds engineering data. And one of those buckets of engineering data is lighting information. And you could actually place a room and a space in the same area in a Revit model, and it's fine. But for that lighting, you can then, if the room has some light fixtures that has photometry, it'll automatically calculate the average estimated illumination. And right here is already shown that these are all built-in parameters. So the 20, 50, 80 rule and 2.5 feet off the floor is where I want to have it calculate that average number. So that's pretty cool. And then here are the rooms in our office that is part of the well building calculation. And this is pretty cool. So the Revit model in the upper left is what I always like to call the single source of truth. And the reason I like software that is integrated into Revit is that it's always working against the single source of truth. When you're using a rendering software like Lumion, you're exporting the model and doing work outside of Revit. So I call it a dead end path. Like you're going to potentially end up having to go back into Revit and make the same changes. So it's not super efficient. Not to say that it's not, you shouldn't do it, but this is just my opinion. Since I got your attention and I'm on the soapbox, that's my story and I'm sticking to it. So you have Revit, single source of truth. From Revit, you can do Enscape, which only allows you to set materials in Revit. It doesn't have any like material that you can apply to Enscape outside of Revit. And then likewise, ElumTools, when you do a calculation, all the results are instantly saved in the Revit model, and all the reflectances are based on the Revit surfaces or the Revit materials. You can toggle and do one or the other. But this is the result. Notice how it says 56 foot candles right there in front of that keyboard. Remember that for a second. And so just as we saw before, you can see the results showing up here in the Revit floor plan. Here's a 3D view of our second floor office. There's that 56 again there on the right, looking at the same desk from a different angle. You can turn on these contours. You can turn on this heat map kind of thing. So you can get some really cool graphics. And actually, I saw there's some questions in the chat. I'll get to those in a minute. And then here's the magical part. So again, 56 was the calculation for our office remodel before the desks were there, before the light fixtures were installed. And then once all that was installed, we dropped this light meter on that same desk and got the, I mean, if you round up, it's obviously off a smidge, but basically the exact same number. And actually, I don't have decimals turned on the right, so it could be that it was the exact same number, because generally it should be the same, all things equal. And here's the final space. So this is that desk. And notice right now the direct indirect only have the indirect turned on, which is actually the best option. If you never see the light source, that's the best scenario. There's less glare, you're getting diffused light. But here it is with the direct turned on, which is obviously, you see how much brighter it is. Sorry, it's not the same angle. Someday I need to go back and put my phone on a tripod and take that same picture twice. So this is a video showing how that works, but really quick, I'm going to look at the questions. So yeah, the question one about the weather affecting it, it 100% is important to have the location on Earth selected when you do a daylight analysis, because that historical weather file actually has the average cloud cover for different times of the day and different times of the year. It also has to do with the light. You know, again, if you're closer to the equator or closer to the North Pole, that has a huge factor on the angle of the sun and how much light gets into the building or not, and how effective a light shelf is. So that's really important. And then for the post-occupancy energy. Not sure, maybe you could unmute yourself if you want. I'm not sure what you mean by without plugins or use of non-invasive monitoring tools or sensors. Sounds really interesting, but I don't quite know what you mean. We can come back to that if you want. Then the third question. So yeah, I'm not going to be showing energy analysis tools, but we actually use Autodesk Insight. It's the total carbon workflow, and also their Revit energy analysis, which is that works just on your computer using Open Studio and Energy Plus. The Autodesk Total Carbon Insight is a Revit model that you push to the cloud. And there's a bunch of videos on my YouTube channel. And actually, I just made an Autodesk course. Let me find that super quick. Free new Autodesk course. Who doesn't like free? And so this course goes through Autodesk Forma and Autodesk Insight. So this goes through the whole process, which is almost exactly how Lake Flato does it. And it's actually quite accurate once you know how all things work, like setting the internal loads and defining the envelope in Revit, and then pushing it to the cloud, which now they have some just recently created new HVAC systems like geothermal, and you can then do embodied carbon analysis. That's also can be fairly accurate. All right, so I'm going to hit go. And this is actually showing the process then to do the electric light calculation. So here's our Revit model. And if you select the window and go to the 3D selection tool, Oh, I just selected those two windows just to have like an extents for that. The selection tool to automatically apply the 3D section blocks in the default 3D view, just so you could have a look inside the building. And so I selected the light fixture, and in ElumTools add-in for Revit, I'm selecting the luminaire manager. And here you can see you can do overrides for something called the light loss factor. You can click and see information in the IES file to see that it's the right one that you've applied to the Revit family. And then you can add the points grid and tell it it's 2.5 feet off the ground. And then you hit calculate. So it's a really straightforward process that you put in the luminaires and you use that luminaire manager to check and make sure that from ElumTools perspective, the light fixture is going to work. And then the next tab up here, the material mapping, is where we can tell it the surface properties of the floor, the wall, and the ceilings. And when you use the override by wall, just anything that's a wall in Revit gets that 50% reflectance. You don't have to set it per Revit wall type. And then you add the points grid, how much spacing there should be. So it's like if you held a light meter in the room and then you walked 3 feet over and then walked 3 feet over again and took readings, that's essentially what you're specifying, the spacing of the light meter and then the height off the floor. And then you can see that 56 there on that desk. And then there's different ways of seeing the results. But as soon as it calculated the results, they're saved in Revit. There's no special save to Revit command because you're technically in Revit. And then here's some really cool heat maps. You can actually make a copy of this view and crop it, turn this stuff on and leave it on. And then when you print, Revit would print that. So I made a Revit schedule. You can see the average illuminance is 34. Here's a 3D view where you can turn on the points, which is cool. You can control the scale of those points and the text size. This doesn't get into that much detail, but this really helps you visualize what you're doing and not having to go out to Rhino and or some other software just makes it, again, super iterative. It's tied to the single source of truth. You don't have to remember if you're working in the most current model. And then finally, and oh, I guess we're out of time. Yeah, so I don't have time to show you this, but
No, we're
Autodesk.
not out of time. We're out of time in 30 minutes.
Oh, we do it. So you do have more time?
Yes,
But
we have 30 more minutes. Yeah.
Okay. But the class, this lecture was only scheduled for an hour?
An hour and a half.
Oh, okay. So I have a half hour?
Yes.
Oh, okay. Well, I have way more time then. So then we'll get back into questions. So Autodesk Forma, please continue.
Yes,
Okay.
please continue.
Unpart. Well, I got confused too about the time because at 5 o'clock, which is an hour from now for me, I have my class that I have to teach. So
we are in Eastern time zone and you're in Central. That's why.
So quick poll, how many of you have heard of Autodesk Forma? Maybe you could just say yes or no in the chat.
Yes, we have heard of this.
That's great. What's really nice about it is that it's free to students, and I highly recommend you use it a little bit. If you're in interior design, so are there architecture and interior design in this in the group here, or is it one or the other?
Why don't you post in chat what your major is? It would be nice for us to know. Yeah,
Okay.
thank you.
Lots of questions. Construction management, awesome. Civil engineering.
Architecture. I'm in architecture.
Okay, thank you. Yeah, that's a really good cross section. So Autodesk Forma is actually becoming like the main thing for Revit or for Autodesk. They're investing just an incredible amount of money in it. They're actually starting to make a version of Forma where you design the inside of the building. It's not currently trying to replace Revit, but it could someday, to be honest. They even just recently announced that they're renaming BIM 360 to Autodesk Forma. It doesn't make any sense to me, but they're calling everything Forma now. And but it's a really powerful tool. So what Forma is right now is it's like a urban development tool, or just a conceptual massing of a single building, where you can do a bunch of different studies, and daylight is one of them. So that's applicable to interior designers. But then for architects and construction management, civil engineering, you can study computational fluid dynamic wind analysis. Before you do that, there's an AI wind analysis tool that gives you real-time directional information that's not quite as accurate, but helpful. It does traffic noise analysis and some other really cool things. So we're going to talk mainly about daylight. And then since we're probably going to have time, I think I'll open Forma and show you some things in there, since it's so easy, super powerful. But there's a feature in Forma called daylight potential. And so after you run this calculation, it shows like this gradient map on the surfaces of all the buildings. And if you click a point on one of those surfaces, it'll give you a reading, a percentage reading. And so if the reading is greater than 27%, a conventional window placed at that spot would usually be satisfactory to get optimal daylight conditions inside the building. If it's between 15 and 20%, you're going to need a larger window to get more light in to get adequate daylight. If it's less than 5%, achieving reasonable daylight is often impossible. And this can happen, like, in New York, there's all these high-rise buildings. And so you're at the lower level of a high-rise building, and across the street are a full street of high-rise buildings. There's no daylight that can get directly to those windows. So that's often where that happens. Or it's on the north side in the winter, where that side of the building doesn't get very good daylight at that time of the year. And so this is what that looks like after you've run the calculation. And then up in the upper left, there's this little inspect tool, and you can start picking points on your building, and it gives you the percentage and conveniently tells you, it says it's daylight potential. And then down here is the legend. And then over here is telling you the percentage of surface that's in, 27 to 37 is the good for, adequate for normal size windows. They actually broke it up into 3 separate bars, just so you can really analyze it. And then you look at the same building from the backside on the right here. The other thing, let me back up 1 second. See all these buildings? So this right here is our office. And then this is a little courtyard that we created, where we deconstructed the roof of a garage. And we actually reused all the wood from that garage inside our building as decorative wood and work surfaces in our phone rooms. But all of these existing adjacent buildings came in automatically. Forma automatically brings in all the context buildings when you first pick your site on the world or on Earth. And so from the backside, there's this view with the points picked. On the left, just for fun, I took a picture from that same location. So this is our office. And random fact, this little yellow building is also owned by our company. And inside it is our wood shop. We have a drill press and a table saw and a bunch of construction tools. Like, people are making models, and some of the furniture in our office, people made themselves. Not me. When I say we made our own furniture, I'm doing the we with the air quotes. And then here is the sun hours comparison. One cool thing that you can do then is there's a compare tool, and there's June 21st, September 21st, and December 21st. So again, you see in the winter, there's a lot less daylight. And so the sun hours, by the way, is different than daylight potential. So again, daylight potential is if you were to put a point, put a window at a specific point. This is just telling you annually how much light would hit that point. On the other hand, the sun hours is a different calculation. And then when you pick points for June 21st, if you were to put a window where that point is picked, there would be 3.6 hours worth of sun hitting that spot during that particular day. On the other hand, that same exact spot in December 21st is only getting 1.8 hours of daylight. And again, that could mean that you're going to make bigger windows, but in Texas, you got to be careful not to make the windows too big, because then you're going to have another problem called solar heat gain. So you can make visual light transmittance and reflectance values to help control that. Speaking of solar heat gain, one of the interesting things about Forma is that it's open and extensible. Autodesk obviously has a huge monopoly on the the AEC market in a lot of ways, but interestingly enough, anybody can create add-ins to Forma. And so there's this company called Fenestra Pro, which has a separate standalone tool, but with their Forma add-in, you can specify the window to wall ratio first for the whole building. And then there's the ability to pick some basic construction types, like what's the wall, the roof, and the glass made out of. And then you run this calculation, like here's where you specify the envelope properties. And you run this calculation and you can tell by each facade, like the north facing face of the building and the south and the east, for the different months, the properties. And so when it gets to red, that means it's too much solar heat gain. It's like going to require cooling. The occupants that sit next to that are going to feel too warm. So then perhaps just on one side of the building, you can change the glass type to cut down the solar heat gain. You might have less visibility through the glass, but it's going to be better performing. And then similar to that course I created, Autodesk also sponsored this YouTube video series I created like a year ago. And there's another add-in called, well, this is a third-party company, but Autodesk baked it directly into Forma. It calculates embodied carbon sort of with really low amounts of information. So you have this simple extruded building, and then using the embodied carbon tool, you can specify the structure type, the general HVAC option, and just a few other things, and it'll give you a total embodied carbon number and an average. So embodied carbon intensity, sort of like energy use intensity. And so here's concrete structure, steel structure, and mass timber. So mass timber is the best performing when it comes to embodied carbon. And so I'm going to, like I said, switch to Forma and show you how it works since it's so easy. Autodesk Forma. I'm going to create a new site. Try and find one of my dummy projects here to put this in. So select project, and then what's the address of your campus? You know it off the top of your head?
1700 Cold Spring Lane.
Is it one word, Cold Spring?
Yes, it's one word, Lane. Baltimore. If you put Baltimore, should pick up Baltimore. Yeah, there we are. Yeah.
I think it dropped the 1700 part. Let's try this. Does that look about right?
Yes.
Okay, so we picked our area. I'm going to really quick confirm map because there's a little bit of processing that happens here. But what's going to happen is it's going to bring in the terrain and the existing buildings. And then this actually ultimately can be brought into Revit, which is really cool. But right now the idea is that you could create some massing in here using their tools of what the building's roughly going to look like, and then do some of these analysis calculations against it. It is possible, and our company almost always uses SketchUp or Rhino, or even sometimes some basic Revit models, and we bring that into Forma rather than using the Forma design tools. But the idea of using the Forma massing has some benefits, which I'll show in a minute. So right now it's prompting me to bring in some other contextual data, but for now I'll just hit cancel just so you can see what happens without even doing anything. So you can see that obviously you don't live on a perfect, or you guys aren't on a perfectly flat site, but I want to see some things like the buildings and the property lines. So I'm going to go back to the tool here, the contextual data command, and I'm going to browse contextual data. And there's different, so if I narrow this down to buildings, there's 3 options here, and it's a little tricky because you don't know, each one of these are from a different source, and one can be more accurate than another, but for a specific area. And then in another area, a different one can be more accurate than the other. So I'm just going to pick the open city model and click add. And so it's specifying the area, which is generally the same as the original thing. I'm going to click order. All of this stuff is free. Unfortunately, the property lines isn't available to students, and I guess Autodesk has to pay for that separately, so they aren't providing it to students. But see it processing over on the left. Once it's done, it should just pop up here. But this is all cloud-based. Yep, so there are the buildings. And there could potentially, like, this building could be 5 stories tall, so that could be one mistake. And those are editable. So let's say you needed to make some changes. Well, let me bring in the other contextual data real quick before I do that. So I'm going to go back to browse and then roads. So right now you could see what looked like a road, but I need to bring in the OpenStreetMap roads. I'm going to click add and order. And then I'm going to close this again. And so where there are roads right now, it was just like part of the map underlay. And now it added this dark area and a center line. And the significant thing is the center line holds data. So over here on the right, I can see that apparently is a 25-mile-an-hour street. If you're going to do this thing called traffic noise analysis, you also have to have the average daily traffic, which is currently set to 0. But usually you can get that from your DOT, like a DOT website. On the street, sometimes you see those little black tubes running across and they're counting how many times cars drive over that. That's what this is, like average daily traffic. How many cars go on that road a day? And so with the speed limit and the average daily traffic, it can actually tell you how noisy it's going to be around the site. And just for fun, here's a blog post that is kind of wild. So I did a sort of a ground truth test. The Apple Watches, there's actually a link here to an academic article on how accurate those Apple Watches are at decibel readings. They're like almost as accurate as professional grade sound equipment. And so I was at a outdoor restaurant, a Chipotle, and I was just, you can see right there where the arrow's pointing. I was this far away from a really busy road that has 80,000 cars drive on it every day. And so 72 decibels. And I went back home and plugged that spot into Forma and ran the same calculation. and got the exact same number, which is wild. I expected it to be within like 10 or 20%, but here's the process. Well, first of all, here's a Google map of the Chipotle, and then these two roads have 80,000 cars go on them a day. And if you go to TxDOT, or in Minnesota, it's MnDOT, I don't know what it's called there, but they have these websites where they're listing all that average daily traffic. So 82,452. And then in Forma, I selected that center line, and then I typed 40,000 because there's actually northbound and a southbound. So each road has 40,000 because this said 82,000 just for the entire thing. It didn't show two roads. And then when you first click to run a noise analysis, it actually does this AI generated result. And then there's a blue button over here to click to do a detailed analysis. And then when you do, here's the result. 72 decibels, 74. So somewhere right in between those two. So maybe it's off again by one, but still generally speaking, the exact same number, which is really wild. So I've added roads, and I'm going to go back to the contextual data. I haven't seen this work very much, but apparently some places they have GIS data that defines tree locations. You can toggle on aerial maps without doing this, but there's some higher quality ones that you can bring in. And then here's the parcel thing that you wouldn't have access to. So this thing called regrid. I'm going to click add, click order. And actually the area is too big for this. So they're, oh yeah, I guess it did work. Sometimes for that, the area is too big and you have to make it a little smaller. And then you'll see the property lines show up everywhere once that's done calculating. So yeah, there they are. One other thing that's cool about Forma is there is an integration that I don't have installed here with Esri ArcGIS. And in here, you can turn on things like floodplains and even socioeconomic data and things like one car driver percentage on the road, or one person in a car versus carpooling kind of stuff. Super interesting things that you can start to study. But if you wanted to edit any of the existing building, like this one needed to be taller and this one was going to be demolished or it's already gone, I can double click on the building, which put me into edit mode for the base. So all the existing stuff is generally not selectable or editable, but I double clicked on it. And so I can select this thing and move it, or I can click to make it taller. So there's some basic things that you can do. And then normally I wouldn't just delete this. On the left here, there's a thing called proposals, and you can make multiple proposals to try different new designs. But usually I'll duplicate this and call one existing, and then one called proposal one. And so the existing one would still have this building, just in case it was planned to be demolished and then they decided not to demolish. You could then bring it back without having to, without having had deleted it. But in this case, just to be quick, I'm going to just delete it and then hit done. So now this thing is ready for the new design. I have this new proposal. Up here, there's some different ways of drawing new stuff. There's a thing called line building, and there's some properties over here, but just without doing anything special, I can do that. I'm going to select that and hit delete. Another thing here is the basic building outline, or actually first another generic one is called house. So if all these were houses over here and they didn't show up for some reason, you could draw them quickly just by doing that, just to get some context in there. There's also, let's see, I don't use this one very often. There's an AI tool that will somehow magically add a bunch of site stuff without me having really given it any details, which is kind of weird. So I'm going to do Control Z to undo that. And then finally, the one that we would typically use the most is basic building. Now you're in a sketch tool where you can specify the footprint of the building. And then you can specify how tall the building is. And then you select the building, and over here you can specify, you can change your mind on the number of floors, but more importantly, there's almost never a 10-foot floor-to-floor height, maybe in a hotel or a dorm room, but a lot of times they're more like 13 or 14 feet. So maybe I'll change that to 6. And then there are ways of switching this thing into what's called a 3D sketch mode, and making the roof slope and doing some more complicated things. But with this selected, notice that the square footage of the building isn't really showing up yet. So with this selected, I can specify the function, and there's some built-in ones, like maybe this is residential. And now the oh, actually, I missed an important step. I need to define the site, where like the site constraints for this project. And there's a command here called site limit. And maybe I'll just generally follow the property line. And now that I've defined the site limit, notice over here, residential, there's 60,000 square feet, but maybe the first floor, I can select that separate. Maybe that's actually a 16-foot high floor-to-floor height, because a lot of times the retail is taller, and maybe that's commercial. So I was able to change just one floor's floor height and its use. So over here, the residential and commercial have different options. For the function, just an FYI, if you click on it again, there's a create new function, so you can have as many as you want. You can create one called retail, restaurant, and then this is starting to calculate all the square footages for you. So this is the value of doing the massing in Revit, Rhino, or Forma, because it's giving you this extra data. If we go to the wind analysis, this is really interesting without having to do actually a full CFD wind analysis. It just used AI to give me a rough idea of what the wind's going to look like. And surprisingly, it's not red between these two pinch points. But if I needed to try and add like something, this part's a little darker, so it is a little bit less ideal. If you look at this, it's comfortable for walking, but not strolling or standing or sitting. So if you're trying to design an outdoor dining area, that wouldn't work very well. So I'm going to create just a piece of 3D geometry, like a little breaker wall. And as soon as I did that, the AI reruns the calculation. And you can see how that little dark spot mostly went away. And I could keep manipulating this. But once I'm done kind of getting this, using this AI as a directional guidance, then I can run what's going to take 30 to 90 minutes to calculate a full computational fluid dynamics, so a CFD wind analysis. I won't do it just because it won't be done by the time we're done. So no sense wasting the data center power, right? Here's the traffic noise analysis. So this actually isn't doing anything right now because, again, you need to have the traffic noise. So I'm just going to make some numbers up here real quick. Oh, I have to get into edit base. So let's say there's 800 cars that drive on this road and maybe 400 on this one. And then I'll just do those two. And then go back to the traffic noise analysis. So I think I confused it a little bit. And this is basically the dark red area is something like usually when you hover over this, it shows you what the reading is, but you know, between orange and red is 65 decibels, and remember mine was 72, which is pretty loud. That's pretty constrained to the road. And then you start getting into the 60 decibels, and then green is good. You can, you know, potentially have a quiet, you know, outdoor event or activity. The daylight analysis. So here's the daylight potential. And this is again the annual thing. So for the site limit, I don't need to know the daylight for everything, just the site. I can click run, and because this is in the cloud, I can switch to the sun hours. And so the other one is annual. This one, you have to specify the days that you want to run. So June, January, September, and you can change the days and then hit run analysis. Looks like we're out of time now.
Yes, we are.
There's one quick question.
Mm-hmm.
Sissy, is it?
Yes, and
Yes.
nice to meet you, Dan. And my name is Cici Han, and I'm currently as assistant professor at the Department of Construction Management, and I'm also the instructor for the BIM class. So there are some students also that joined the workshop today. So
Yeah.
last, I have one question. Is that and so first, I think I need to thank you for your awesome presentation. There are so many interesting and impressive perspectives and in this workshop. So my question is that, and do you have any good suggestions and resource to help students learn the BIM software, especially the Revit?
Boy, Abby knows my answer to
Your
that.
book, his book.
The book, yeah, because right now we use a textbook which is prepared by you, the commercial design, using the Autodesk Revit.
Yeah. So that one is good because it goes through structure, MEP, and then in the online files, there's actually a class on ElumTools that you can download, like a chapter on how to use the lighting calculation software. And then that Autodesk certification that I put in the chat, that's actually quite a bit of material that students can work through. And it's really interesting because it's based on a real site in downtown Austin. It's all fictitious, but there's a program and you have to build the right floor area ratio, the FAR, based on the city's zoning code, and then run calculations. And I changed the building orientation and the layout to get different, like, improved results throughout the course. But yeah, the commercial, so there's did you say commercial design book?
Yeah.
Yeah, that's the most basic book that I've written. I would say that the design integration book is better. That's the one that
Okay.
structure and MEP.
Design
There's
integration.
also an interior design book that is based on the same, like, Revit model as the design integration. In the Revit, in the interior design book, you get the core and shell model of this 2-story law office. And it's a little bit more intermediate to advanced because you're downloading real world manufacturer furniture, casework, even finishes like the Sherwin-Williams paint color, you're defining, getting the RGB value for the paint from the website. So between those two books, it's really quite, students learn quite a lot.
Okay, thank you.
We
Yeah,
can talk more about that too if you want to email me or connect and get my email from Abby.
okay, yeah, I will check and I'll and also trying to get your email. Thank you.
Yeah, and there's another question there from Derek about downloading the data into Excel. I've recently asked Forma for that because you can't, and I've done it manually to feed it into ChatGPT to get some even more interesting results about comparing all the analysis results for multiple designs. So that's a really good question. Very, very, the fact that you're great minds think alike.
I'm
All right,
also popping into chat the link to your SDC books. The link to your SDC books, so people will be able to get your books there as well.
Thank you. Okay, well, I better go. I have to...
Thank you so much. We should give him a huge round of applause. I know you have to leave to teach your other class, but we'll bring you back again.
Yeah, especially with this
Thank
class.
you.
Thank you so much. Yeah,
Thank
thank
you.
So engaging and asking questions. That makes it fun.
It's been great.
Yes, thank you.
Okay. Bye, everyone.
Yes, thanks everyone for joining. You'll hear more
Thank
from Professor Shanklin and I about the Knuckles program as well. Bye.
Bye.
Lighting program. Bye. Thank you.